Hello everyone, my name is Purnanand Dalasai Pare. My student ID is 230350101250. I am a student of BSc Honors in Data Science and Artificial Intelligence online degree program at IIT Guwahati. Today I am presenting my project for course DA 378, which is uh, DA 378 for trimester 7. My project is regarding credit card fraud detection using machine learning program. The object of this project is to identify fraudulent credit card transactions using machine learning model and provide an easy to use web application for fraud predictions. Let me start by telling you what problem this project solves. Credit card fraud occurs when someone uses another person's card information, credit card without their permission. As online transactions are increasing every year, fraud detections has become a major challenge for banks and financial institutions. The main challenge is that fraud is very rare. In a data set of 1000 transactions, only 4 to 10 transactions may actually be fraud. This is called a class imbalance fraud. Because of this imbalance, a simple model may achieve very high accuracy simply by predicting everything as a legitimate. So we need a special techniques to handle these problems. This is exactly what my project focuses on. For this project, I use the following tools and technologies. Programming language is Python. For data handling, I use Pandas and NumPy. For machine learning, I use Scikit-learn. For making graphs and charts, I use Matplotlib and Seaborn. For the web application, I use Streamlit. Now let me show you the data. I use the SparkBow synthetic credit card fraud dataset. This dataset has 64,052 transactions from January 2019 to December 2020. It has 23 columns. Out of 64,052 transactions, only 270 are fraud. Uh, this uh, uh, this is less than 0.5%. So you can clearly see the class imbalance. Here the important columns are Here the important columns are transaction amounts, transaction amounts. Important columns are transaction. Important columns are transaction amount, which is the amount column. The transaction date and time. The merchant category like groceries or shopping. The customer location as latitude and longitude. The merchant location. Our target column is fraud, where one means fraud and zero means legitimate. The first step is data cleaning. Now I drop all the columns that are not needed. I removed the row index, transaction ID, credit card numbers, name, street address, jobs, and date of birth. These columns have personal informations and no real patterns for fraud. I also filled missing values in the category column with the word unknown, and I checked for duplicate rows. There were no duplicate rows. Now, next step is handling class imbalance. This is a very important step. As I mentioned, only 0.5% of transactions are fraud. If if I train a model on this imbalanced data, the model will simply predict everything as not fraud and still get higher accuracy, which is wrong. To fix this, I used oversampling. I made copies of fraud rows in the training data until I had equal number of fraud and legitimate transactions. This is called oversampling the majority class. One very important thing, I only oversample the training data and not the test data. If I oversample the test data also, my evaluate result will be fake. Must always look like the real world. After this, I created new features from this existing data. This is called the feature engineering. From the transaction date and time, I extracted hours, day of weeks, months. Okay, huh. I also calculated the distance between customer and merchant location. This is useful because fraud often often happens at unusual timings like midnight or very early morning. I also calculated distance in kilometer between the customer's location and the merchant location using the latitude and longitude values. The formula for this is square root of difference in latitude plus square of difference in longitude. And to convert this from degree to kilometers, I multiplied by 111. If a customer is very far from the shop where a transaction happens, this could be suspicious. Then I did label encoding of columns like category, gender, and city into numbers using the label encoding. As we know that machine learning model only works with numbers and not text. Now, by using a heat map, I tried to find correlation between all the variables. Now, to train the model, I split the data into training and test split. 80% I use for training and 20% for test splits. Now, for model training, I trained and compared the three machine learning models. The first model is logistic regression. This is the simplest model. It uses a formula called the sigma mod function, which gives a number between 0 and 1. If the number is about zero point 0.5, the model predicts fraud. Think of it as drawing a straight line to separate a fraud and non-fraud transaction. The second model is decision tree. A decision tree asks yes or no questions on a feature. For example, the transaction amount is 200. If yes, then ask, is the distance greater than 50 kilometers? If yes, predict fraud. It creates if else rules automatically. I set the maximum depth up to 6 so the tree does not become too complex and overflow. The third model is random forest. Random forest combines multiple decision trees. Random forest builds 100 decision. Here I use 100 decision trees. Each tree is trained on different random parts of data, which I give a new transactions. Each tree votes on the predictions. Is it a fraud or not? Because it uses many trees together, it generally perform better and produce more reliable predictions. Hmm. Now let me show you the result. I use five metrics to evaluate my model. First is accuracy. This shows how many predictions are correct out of all predictions. The second is precision. This shows out of all transactions predicted as fraud, how many are actually fraud. The third one is recall. Out of all actual fraud transactions, how many did the model catches? The fourth is F1 score, average of precision and recall. The fifth one is ROC AUC. This measures how well the model can separate fraud from legitimate transactions. A score of 1 is perfect and zero point 0.5 is bad as a random guess. For this project, recall is the most important metric. We do not want to miss any real fraud. If we miss a fraud, the customer loses money. It is better to have a false alarm than to miss actual fraud. Logitech regression got ROC AOC of 0.941 and recall of uh, 0.870. Decision tree got ROC AOC of 0.901 and recall of 0.852. And the random forest got the best result with ROC AOC of 0.970 and recall of 0.85. So the random forest is the best model. It correctly identifies 85.6% of all fraud transactions. By looking all of the above points, random forest model is the best model and we will save it and proceed further. Now we will see the front end part of this project. This is my front end code. I had used here Streamlit, and now we will run it. Now we will upload here upload the sample data set to get the result. Now you can see here from 19,721 transactions, 143 were for fraudulent, and 19,578 transactions were legitimate. This is the descriptive statistics form where you can see the data, and this is the uh, sample rows. You can see the how the class is imbalanced. Uh, how the class is imbalanced, and this is in a pie chart. So thank you. This is my project regarding the credit card fraud transaction. Thank you.